In this lesson, we are going to set up a physical animation component in order to set up a ragdoll simulation. Now, a ragdoll simulation applies physics, and so in this case, we've got a robot that's doing its job, and let's pretend that suddenly the robot is starting to lose power. So we hit the button and it starts to lose power, and then let's say it gets the power back. So I've set this up in a way that we can make it interactive. This is the kind of same thing where sometimes you would have a character that maybe would get hit by a bullet, and then if the character's killed, we can go full ragdoll, or you could let the character get back up. All right, so this is a very simplistic approach, and we're using the physical animation component, but it's a good start to understanding the concept. So let's just jump in. As you get more complex and set up blueprints, you can simply add the component itself into a blueprint. So you could say physical animation component. So there it is, physical animation. But since I'm keeping these simple, we can just do this in the level blueprint. As a simple example, this works. I'm hitting the 7 key, and I'm flip-flopping between playing the animation and reversing. And what am I doing? All I'm doing is taking this timeline and setting a value from 0 to 1 over 2 seconds. So we'd set this to 1 second, 2 seconds, and then the output of that float, I'm calling the blend weight amount. And between 0 and 1, this blend weight is going to eventually pipe into set all bodies below to a physics blend weight. So we could even just stop at 50% if we wanted to on this timeline. So we could go from 0 to 0.5 if we thought that looked better. Going to full 0 is kind of the robot just dragging itself completely based on physics. Okay. The first thing that we're going to do, since this is simply a skeletal mesh, we are going to add the physical animation component. So just typed add physical animation component. And then I selected the robot and I right-clicked and created a reference to it, dragged off and said set all bodies below to simulate physics. There it is. Plugged it in and it added this target skeletal mesh component. And what is this looking for? Well, it's looking for certain bones. So it's saying every bone below, and then it's saying, well, what bones are we going to put below? So let's take a look at the skeletal mesh for a second. Take a look at which one I chose. So I'm hitting Control E to open that up. So I chose, in this case, bone 3. Because I didn't want the base to flop over. So I wanted to look like it lost power, but maybe that this was drilled into the ground. But you could have actors completely fall to the ground. So let's go back. And so I just created a variable, and this is a name variable. So I could just drop in whatever I wanted. And making this, since this is in the level blueprint, it's not really going to make a difference in terms of if this is exposed or not. But if this was an actor blueprint, you could try out different bone names and just keep this public. So let's move on. Then the final step is just to set all bodies below the physics weight to the weight that we've specified. And you want to plug in the asset, and you plug in the bone name. And just to mention that this is it's still listed as an experimental feature. And I also set this to auto activate. So if you didn't see your animation working, you might want to turn this to auto activate. So let's see it one last time. But it's a pretty simple example. It's an effective demonstration of a ragdoll simulation. So let's hit the 7 key. And it starts to get wobbly. And let's hit 7 again, and it's back. Okay, one last thing to mention. Let's open up the skeletal mesh. In the physics area, before we leave this, there are a lot of additional physics elements that you can set constraints and dampening in here to improve the look of this physics asset in terms of how it collides with things, in terms of maybe like you saw some of these wobbling in ways that they probably shouldn't based on the joints. I didn't take the time, but it's possible that you could add a damping on certain angular rotation. Wanted to mention that before wrapping this up. Okay, we've covered a nice overview of how to set up a ragdoll simulation with a skeletal mesh and transition between the animated component to the physics-driven component. That'll wrap things up. We'll see you in the next video.